You use abstraction every single day without even realizing it. You drive cars without understanding engines. You use smartphones without knowing what happens inside the processor. You click buttons, and somehow, thousands of hidden operations begin instantly. But have you ever wondered why modern technology feels so simple despite being insanely complex underneath? What if there's one invisible concept silently powering all of this? That concept is abstraction. So, what exactly is abstraction? In the simplest words, abstraction means showing only the important things while hiding unnecessary complexity. It focuses on what something does, not how it works internally. Think about a car. You only interact with the steering wheel and pedals. You don't need to understand engine combustion just to drive. And that's the beauty of abstraction. It turns complexity into simplicity. Our brains are not designed to handle endless complexity all at once. Imagine if every time you used your phone, you had to understand networking, memory allocation, processors, and operating systems. Technology would become exhausting. Abstraction reduces mental overload. It allows humans to focus only on what truly matters. In many ways, abstraction is the reason modern technology feels usable. Driving a car is one of the best examples of abstraction. When you drive, you interact with a very simple interface: the steering wheel, the accelerator, and the brakes. But underneath that simplicity, thousands of mechanical operations are happening continuously. Fuel combustion, engine synchronization, gear systems, cooling systems. Yet, the driver never needs to see any of it. You control the result, not the complexity. Your smartphone is basically a giant abstraction machine. You tap an app icon, and instantly things happen. Messages are sent, data travels across servers, memory gets allocated, processors execute instructions. But none of this complexity is visible to you, and that's intentional. Good technology hides complexity. So humans can focus on experience instead of implementation. In programming, abstraction works the same way. Developers create simple interfaces for extremely complex systems. For example, when you call a function, you usually don't care about every internal step happening behind the scenes. You only care about the result. That's abstraction. Good software hides chaos behind simplicity, making systems easier to build, use, and understand. Abstraction is one of the biggest reasons modern software development is even possible. It reduces complexity, improves readability, makes code reusable, improves security, and makes maintenance much easier. Without abstraction, programmers would constantly drown in low-level details. Instead, abstraction allows developers to build massive systems, layer by layer, without getting overwhelmed. There are mainly two types of abstraction. First, data abstraction. This means hiding unnecessary data details from the user. Second, process abstraction. This means hiding implementation steps. For example, when you use an ATM, you only see a simple interface. You don't see the banking systems, security checks, or database operations happening internally. Again, simple outside, complex inside. Many people misunderstand abstraction. Some think abstraction only means hiding variables. Others think it's purely theoretical. But abstraction exists almost everywhere in technology. At the same time, more abstraction is not always better. Too much abstraction can actually create confusion if systems become overly hidden. So the goal is balance. Abstraction should simplify things, not make them mysterious. Now comes the biggest confusion in object-oriented programming: abstraction and encapsulation. They sound similar, but they solve different problems. Abstraction hides complexity. It focuses on behavior and usability. Encapsulation hides data. It focuses on protection and control. A simple way to remember this is abstraction asks, what should the user see? Encapsulation asks, what should the user not directly access? Here's the simplest way to remember the difference forever. Abstraction hides complexity. Encapsulation hides data. Think of a car dashboard. You only see controls. That's abstraction. Now think of a locked safe protecting valuable items. That's encapsulation. One simplifies interaction. The other protects information. So, how does Python implement abstraction? Python uses abstract classes and abstract methods. These are created using the ABC module. An abstract class acts like a blueprint. It defines rules that child classes must follow, but the actual implementation is left incomplete. This helps programmers create structured, predictable systems. Here we create an abstract class called animal. Inside it, we define an abstract method called sound. Notice something interesting. The method has no real implementation. Why? Because the class is only defining a rule. It's saying any child class must provide its own version of sound. This is abstraction in action, defining expectations without exposing implementation. Now we create a dog class that inherits from animal. This class finally implements the sound method and returns bark. The abstract class created the blueprint. The child class completed the behavior. This creates cleaner, more organized code structures. In simple words, abstraction defines what should happen, while child classes decide how it happens. Abstraction exists almost everywhere in modern software. APIs, game engines, operating systems, AI systems, frameworks, cloud platforms. All of them hide enormous complexity behind simple interfaces. And that's why abstraction is so powerful. It allows humans to interact with incredibly advanced systems without needing to understand every internal detail. So after everything we explored, here's the golden rule of abstraction. Hide the complexity. Show only the essentials. That single idea is one of the foundations of modern programming and modern technology itself. Because true intelligence in software is not about exposing complexity. It's about making complexity feel invisible. So guys, this is all about abstraction. I hope you understood the topic. And if not, then don't worry, with practice, everything will start making more sense. If you enjoyed this video, then smash that bell button or whatever else you feel like smashing. Just don't break your device. In our next video, we'll be covering inheritance. And I know you all are absolutely dying to watch that one. Till then, bye-bye. And don't miss me too much.